So here is another question on solving arithmetic progression, the sum of n terms of an arithmetic progression. So here it is given in an arithmetic progression of 50 terms, the sum of the first 10 terms is 210 and the sum of its last 15 terms is 2565. We have to find the arithmetic progression. Okay. So here let's say for this given arithmetic progression, the first term, that is equal to a, and the common difference, that is equal to d. We have the first information which is given is that there are a total of 50 terms in this given arithmetic progression. The sum of the first 10 terms is 210. Okay, so let's say we have first 10 terms. Okay, sum of the first 10 terms, 1 to 10, let's call it S10, that is equal to 210. Now we know that the sum of n terms, it is given by n by 2 to 2a plus n minus 1 into d. Okay, this is the sum of n terms. So if we write it in terms of a and d, it will be equal to, that implies 10 by 2 into 2a plus 10 minus 1 into d, that is S10. Okay, S10, that is equal to 210. That implies 5 into 2a plus 9d is equal to 210. That implies 2a plus 9d is equal to 210 by 5. That is equal to 42. So we have the first equation, 2a plus 9d is equal to 42. Then we have the other piece of information is that the sum of its last 15 terms for this AP is 2565. Okay, so how we can use this information? So let's say we write the terms for the given AP. The terms that are important, we have T1, then we have T10, then we have T35, it will be a little bit farther away. T35, then T36, and then we have T50. Total 50 terms are there. So the sum of first 10 terms, that is 210. We have used that information to write this equation. Then it is given that the sum of the last 15 terms, that is from 36 to 50, the sum of the last 50 terms, that is equal to 2565. So we can write that the sum of the last 15 terms, okay, that is from 36 to 50 here, okay, the sum from 36 to 50. Okay, 36 to 50, it is equal to the sum of the total 50 terms. Please pay attention. The sum of the total 50 terms minus the sum of the first 35 terms, that is from T1 to T35. Okay, this is very important. The sum of the last 15 terms, that is from 36 to 50, T36 to T50, it is the same as writing the sum of the total 50 terms from T1 to T50 minus the sum of the first 35 terms from T1 to T35. Okay, so we will be writing it in terms of A and D. So this is equal to how much? 2565. Okay, this is the very important relationship. So now we'll be writing S50 and S35 using the sum of n terms formula in terms of A and D. So this is the important relationship. The sum of the last 15 terms is equal to the sum of the total 50 terms minus the sum of the first 35 terms. Okay, this is the important relationship. Now that implies for S50 it is n by 2 into 2a, okay, plus n minus 1, that is 50 minus 1 into d, minus n by 2, that is 35 by 2 into 2a plus 35 minus 1 d, that is equal to 2565. That implies here it is 50 by 2 is 25 into 2a plus 49d minus, here this will be 35 by 2 into 2a plus 34d, that is equal to 2565. So that implies 25 to 2a plus 49d minus 35 by 2 into 2 into a plus 17d is equal to 2565. 2 gets cancelled, so we have, that implies here 25 into 2 is 50a plus 25 into 49, that is equal to, it is 94, it is coming around 1225d, okay, 1225d minus 35a plus 595d, okay, 350, yes, 300 and plus, yes, 595d, that is equal to 2565. Okay, so that implies 50a minus 35a plus 1 225D minus 595D is equal to 2565. Okay, so that implies this is 15A plus this is how much? Okay, it's 630, I think. Yes, 630. 630D is equal to 2565. That implies if we take 15 common, it will be 15 to A plus this is 642. 42D is equal to 2565. That implies A plus 42D is equal to 2565 by 15. So this is, we have 23, this is 5, 1, 3, and then again 3, 1, 7, yes, 171. So that implies A plus 42D is equal to 171. So this is the second equation in terms of A and D. We have the first equation is 2A plus 9D is equal to 2A plus 9D is equal to 42. This is the first equation. And the second equation is A plus 42D is equal to 171. 2A plus 9D is equal to 42. A plus 42D is equal to 171. So let us say we write the two equations. Okay. A plus 42D is equal to 171. Let's say we multiply 2 on both sides. So it becomes 2A plus 84D is equal to how much? 342. And we have 2A plus 9D is equal to 42. So if we subtract these two, we will have 2A minus 2A cancelled, 84 minus 9, that is 75D, and this is equal to 300. That implies D is equal to how much? 300 by 75. So this is 4. D is equal to 4. So common difference is 4. Now we can put it here in A plus 42D is equal to 171. That implies A is equal to 171 minus 42D equal to 171 minus 42 into 4 equal to 171 minus 168, which is equal to 3. So we have the first term is equal to 3, the common difference is equal to 4. We were asked to form the AP, to find out the AP. So the arithmetic progression will be the first term 3, the next term 4 greater than that, so it will be 7, the next term 4 greater than that, 11, next term 15, then 19, and so on. So this is the required arithmetic progression. Okay, so it was a bit lengthy, but the trick here is this equation, determining this equation, that the sum of the last 15 terms, it is equal to the sum of the total 50 terms from the forward, from the first minus the sum of the first 35 terms. Okay, that is equal to this. Then we wrote it in terms of A and D. We got two equations. That is for the first one, which is from the sum of the first 10 terms, and this is from this. So we use the two equations to cancel out the common variable, the variable cancellation method. We cancelled out the A thing, we got the common difference, we used that to get the first.